Let us have a look at question 3 and 4 from a KZN June 2019 exam paper. So we are only focusing on the trigonometry questions from this exam paper. So we have question 3.1. In the diagram below, P, which has coordinates -16 and Y, is a point such that OP is equal to 20 units and reflex ROP is equal to theta. So please keep in mind that when it comes to a coordinate point, you're always given X first and then Y. So we now know that -16 is the X value of this triangle and Y is unknown. However, keep in mind Y would be negative because it is below the x-axis. It is in quadrant 3 where Y is negative. Now OP is the side over here. This is the hypotenuse of the triangle. It is the side opposite the right angle, or you could say the 90-degree angle. Now, our first question states 3.1.1, calculate the value of y. Now, we have 2 out of the 3 sides of this right-angled triangle, so we can use the theorem of Pythagoras. So, let us get started. So, we know that x is equal to -16, y is unknown, and the hypotenuse is 20. From here, we will state the hypotenuse squared is equal to x squared plus y squared. And our reason is Pyth, or you could just say the theorem of Pythagoras. But Pyth is much shorter. So we have 20 squared, that gives us 400, -16 squared, that gives us 256 plus y squared. Now we are going to move all the constants to one side, add them up, and that gives us y squared is equal to 144. From here, we can square root both sides, and we have y is equal to positive or negative 12. Always remember, when you square root something, it is positive or negative. As we previously mentioned, y is below the x-axis, so it is going to be negative y. So we'll state, therefore, y is equal to -12. And that is it. Let us just complete our labels. Now, our next question is 3.1.2. So question 3.1.2 states, determine the value of each of the following without using a calculator. So we are going to use the information from the diagram provided to answer questions A and B. So we have sine of 180 minus theta. So we know 180 minus theta, that is in quadrant 2. Sine is positive in quadrant 2. So this is going to become positive sine, and we bring down the angle theta. So we need to go back to our diagram and identify what is sine theta equal to. So we know that sine theta is equal to the opposite, which is -12 over the hypotenuse, which is 20. So we therefore have sine of 180 minus theta as equal to -12 over 20. Now always make sure that your ratios are simplified as far as possible. So just put this into your calculator, negative 12 over 20, and you are going to end up with negative 3 over 5. So that is it. Sine of 180 minus theta is just equal to negative 3 over 5. Next, let us have a look at question B. So we need to determine the value of cos of 180 plus theta. So here we know that 180 plus theta, that is quadrant 3, and cos is negative in quadrant 3. So this is going to become a negative cos of theta. And we need to identify what is cos theta equal to. So we go back to our diagram. We know that cos is equal to the adjacent, which is negative 16, over the hypotenuse, which is 20. So that will be negative into negative 16 over 20. We can put that into our calculator and we end up with 4 over 5. So that is it. All you needed to do was reduce the ratios given, use your diagram, find the opposite, the adjacent, the hypotenuse, substitute them, and that is it. Something very important to take note of is that your sine ratio is equal to the opposite over the hypotenuse. Your cos ratio is equal to the adjacent over the hypotenuse. And your tan ratio is equal to the opposite over the adjacent. In addition to this, 16 was our adjacent side, negative 12 was our opposite side, and 20 was our hypotenuse. So that is question 3.1.2. Next, we have question 3.1.3. S is a point on OP such that OS is equal to 15. Determine the coordinates of S without using a calculator. So we were told that OS is 15. That is the hypotenuse of the smaller green triangle. Now we need to calculate the coordinates of S, which is the X value of the triangle and the Y value of this triangle. Something that is important to take note of is that the angle theta for both the larger triangle and the smaller triangle is the same. So this is the angle theta. As you can see, it is the same for both triangles. So we can use simultaneous equations and their ratios to calculate x and y. X is the adjacent, so we will use cos. Y is the opposite, so we will use sine. So let us attempt question 3.1.3. As mentioned earlier, we know that theta from the triangle P is equal to theta from the triangle S. They have the same angle, which means their ratios are also equal. So to find x, we are going to use the cos ratio. So I'm going to say cos of theta for the red triangle, for the triangle with point P, is equal to negative 16 over 20. And cos theta for the triangle with point S is equal to the adjacent, which is x, over the hypotenuse, which is 15. Now, because the angle theta is the same for both triangles, we can connect them. So that is going to be negative 16 over 20 is equal to x over 15. From here, we will cross multiply and end up with negative 16 times 15 all over 20 is equal to x. We can put this into our calculator, and we therefore have x as equal to negative 12. So that is it. We have used simultaneous equations as well as our ratios to calculate the value of x. Next, let us attempt to calculate y. To find y, we are going to use our sine ratio. So we are going to use sine theta of the triangle with point P is equal to the opposite, which is negative 12, over the hypotenuse, which is 20. And then we are going to use sine theta for the triangle with point S, and that is equal to the opposite, which is y, over the hypotenuse, which is 15. From here, we connect both ratios because they are equal to each other. We can cross multiply and we therefore have our value of y as equal to negative 9. From here, we can conclude that the coordinate of S is negative 12 and negative 9. And that is it. All we needed to do was understand that the angle theta for both triangles is the same. From there, we were able to connect the ratios and solve for x and y. Now, let us have a look at the last question under question 3. Simplify without the use of a calculator. We've got cos of negative 33 times tan of 147 all over 2 cos of 303 times sine of 240. So this is question 3.2. Let us get started. Now, the first thing you should notice is that negative 33 is a negative angle. So we are going to add 360 to make it a positive angle. So when we add 360, keep in mind it is going to be negative 33 plus 360. That is going to give us 327. From here, let us identify which quadrants our ratios are in. So 327, that is quadrant 4, and cos is positive in quadrant 4. 147, that is quadrant 2, and tan is negative in quadrant 2. 303, that is quadrant 4, where cos is positive. And lastly, 240, that is quadrant 3, where sine is negative. Now, cos of 327. Because cos is positive in the fourth quadrant, that will become positive cos. Now we need to reduce the angle. So because it is the fourth quadrant, I'm going to take 360 minus theta, which is the reduction formula in the fourth quadrant. and I'll make that equal to 327, which is the angle we have been given. From here, I'm going to solve for theta, which is then going to be 33. So cos of 327 will become cos of 33. Please keep in mind, this is not the only way in which you can reduce an angle. There are many ways. This is just a method that I like to use. So I take the reduction formula in that specific quadrant, I make it equal to the angle given in the question, and I solve for theta. Now, let us have a look at the next one. Tan of 147, that is in the second quadrant, where tan is negative. So we'll say negative tan. Because it's the second quadrant, we will use the reduction formula 180 minus theta, and it will be equal to the angle given in the question. From here, we solve for theta, and this is going to become 33. So tan of 147 becomes negative tan 33. Next, let us have a look at the denominator. So we've got cos of 303, that is in the fourth quadrant, so cos is positive. Let us reduce 303, because it's in the fourth quadrant, we'll use the reduction formula. 360 minus theta is equal to 303. From here, we solve for theta, and that is 57. So this becomes 2 cos of 57. Then we have sine of 240. That is in the third quadrant where sine is negative. So that will become negative sine. Because it is the third quadrant, we'll use the reduction formula 180 plus theta, make that equal to the angle given. From here, we can solve for theta, which will be 60. So sine of 240 gets simplified into negative sine of 60. Something important to take note of is we have negative on top, negative at the bottom. They cancel each other out. So this becomes cos of 33 times positive tan of 33 all over 2 cos of 57 times positive sine 60. So all we did was cancel out the negative signs. From here, something that is important to take note of is that tan is equal to sine over cos. That is an identity. So we can replace tan with sine over cos. Now, something important to take note of is cos of 33 cancels cos of 33. Same thing on top, cancels the same thing at the bottom. And we are then left with sine of 33 over 2 cos 57 times sine of 60. Another thing to take note of is that sine 60 is a special angle. We can put this into our calculator, and sine 60 gives us the square root of 3 over 2. So sine 60, we put the square root of 3 over 2. Take note that sine 60 becomes square root of 3 over 2. And 2 at the bottom cancels out 2 on top. And we're then left with sine of 33 over the square root of 3 cos 57. Something important to take note of is that 33 plus 57 is equal to 90. So we are dealing with co-ratios. We know that whenever we have two angles that add up to 90 degrees, and one is sine, one is cos, one is on top, one is at the bottom, they cancel each other out. Take note that co-ratios have the same magnitude, they're equal to the same thing. So if you put sine of 33 into your calculator and you put cos of 57 into your calculator, they will give you the same value. So they cancel each other out, therefore giving us 1 over the square root of 3. So that is it. We were able to simplify question 3.2 into 1 over the square root of 3 using reduction, identities, and co-ratios. Next, let us have a look at question 4.1. Use trigonometric identities to prove that sine cubed x plus sine x cos squared x all over cos x is equal to tan x. So we need to prove that the left-hand side is equal to the right-hand side. If we want to try to get tan x, we need to try to get sine over cos. If you notice, we already have cos in the denominator. So we need to try to get the numerator to be sine only. So as you can see on the left side, we have a common factor of sine x. So we're going to take out this common factor of sine x, leaving behind sine squared x plus cos squared x, and that is all over cos x. If you struggle to take out a common factor, just divide. So you take the first term, which is sine cubed x, and you divide it by the common factor. The common factor is sine x. Now, if you notice, you've got the same base, which is sine x. So you write the base once, and you subtract the exponents, 3 minus 1. That'll give you sine squared x. So you take the second term, which is sine x cos squared x, and you take out a common factor, which is sine x. So you divide by sine x. And as you can see, sine x cancels sine x, and you are left with cos squared x. So that is what is left behind in the bracket. So if you want to take out a common factor, you just divide each term by that common factor to see what is left behind inside of the bracket. Now, from here, take note that sine squared x plus cos squared x is equal to 1. That is an identity. So that is going to leave us with sine x into 1. That sine squared x plus cos squared x inside the bracket just became 1. And that is all over cos x. From here, all we are going to do is multiply sine x by 1. So sine x times 1 is just sine x. And that is over our denominator of cos x. Now, please take note of the identity sine x over cos x is equal to tan x. So in place of sine x over cos x, we're just going to replace it with tan x. And that is our right-hand side. We have now proved that the left-hand side is equal to the right-hand side. All we needed to do to get tan x was get sine over cos, which we did. So we can therefore state that the left-hand side is equal to the right-hand side. And that is it. That is question 4.1. Take note that sine squared x plus cos squared x is equal to 1, and sine x over cos x is equal to tan. Next, let us have a look at question 4.2. If sine x is equal to 0.412 and x is an element from 0 to 360, so we need to solve for x. Please take note that sine x is equal to something positive, which means our answers are going to be in the two quadrants in which sine is positive in. So sine is positive in quadrant 1 and 2, so our solutions will be in quadrant 1 and 2. If sine was equal to something negative, then our solutions would be in quadrant 3 and 4. In addition to this, we are going to need to find a reference angle so that we can get our solution in quadrant 2. So let us get started. So please take note that if sine x is greater than 0, meaning that it is positive, then our solutions are going to be in quadrant 1 and quadrant 2. But if sine x is less than 0, meaning it is equal to something negative, our solutions would be in quadrant 3 and quadrant 4. So please keep that in mind. So from here, all we are going to do is move sine over to the other side in order to get a reference angle so we can find our solution in quadrant 2. So here we are going to say our reference angle is equal to sine inverse of 0.412. We can put this into our calculator, and our reference angle is then equal to 24.33. Anytime you need to find a solution in quadrant 2, 3, or 4, or basically any quadrant that is not quadrant 1, you need to find a reference angle. So let's start with our solution in quadrant 1. So our solution in quadrant 1, we are going to say x, which is the angle, is equal to the reduction formula in quadrant 1, which is just theta. And that is going to be our reference angle. So instead of using theta, I'm just going to say angle. So from here, our solution in quadrant 1 is therefore equal to 24.33. And then our solution in quadrant 2, our reduction formula in quadrant 2 is 180 minus the angle. So we substitute our angle. We can put this into our calculator, and we therefore have x as equal to 155.67 degrees. So that is it. Please take note that because our solution was in quadrant 2, we needed to find a reference angle. If we only had a solution in quadrant 1, we would have just taken sine to the other side and got x is equal to 24.33 and ended it there. Anytime you have a solution in quadrant 2, 3, or 4, you need to find a reference angle to find the solution in that quadrant. In addition to this, the reason that we did not state plus k times 360 where k is an element of integers is because this is not general solution. In addition to that, our solution was restricted. Plus k times 360 means that our solution is going beyond the angle of 360. It is bigger than 360. But if you remember, they stated that x needs to be within 0 to 360, so it cannot be bigger than 360. That is why we don't say plus k times 360. So all we needed to do was identify that because sine is equal to something positive, our solutions are going to be in quadrant 1 and 2 because sine is positive in those quadrants. If it was equal to something negative, for example, if we had sine x is equal to negative 0.412, we would have used quadrant 3 and the reduction formula 180 plus angle, and quadrant 4 and the reduction formula 360 minus angle. So please keep that in mind. In addition to this, if sine was equal to something negative, we would not have used the negative to find our reference angle. The positive and negative just tells us which quadrant our solution is in. So we do not use the negative to find the reference angle. You ignore the negative sign when finding a reference angle. Next, let us have a look at question 4.3. Consider the equation tan 3x plus 2.64 is equal to 0. Determine the general solution of tan 3x plus 2.64 is equal to 0. So the first thing we are going to do when finding the general solution is to solve for the ratio. We need to get tan 3x is equal to something. Then we need to identify, is it equal to something positive or is it equal to something negative? If it is equal to something positive, we will use quadrants 1 and 3 for our solutions because tan is positive in those quadrants. If it is equal to something negative, we will use quadrants 2 and 4 for our solutions because tan is negative in those quadrants. Then we will find a reference angle. Take note that if tan is equal to something negative, you ignore the negative sign when finding the reference angle. And then lastly, we use those quadrants to find our solutions. So let us get started. This is question 4.3.1. So we have tan 3x plus 2.64 is equal to 0. From here, we are going to solve for tan 3x. We solve for our ratio by moving 2.64 to the right and making it negative. Now we know that tan is equal to something negative. So please take note what was mentioned earlier. If tan 3x is positive, we are going to use quadrants 1 and 3. But if tan 3x is equal to something negative, we are going to use quadrants 2 and 4. Now, as you can see, we have a negative answer for tan. Tan is equal to negative 2.64. So our solutions are going to be in quadrant 2 and 4. Now, let us find a reference angle. To find a reference angle, we are going to move tan to the other side, making it tan inverse of 2.64. Don't forget to ignore the negative sign when finding a reference angle. Now, we can put this into our calculator. So our reference angle is then going to be equal to 69.25. Now, our solutions, as previously discussed, are going to be in quadrant 2 and 4. So let's start with that. Please take note that we are going to say 3x is equal to, because that is the angle of tan. When you find your solution in the specific quadrants, you take the angle as it is, whether it was 2x or x plus 10 or x minus 10 or 3x. You take the angle as it is. The angle that comes after the ratio, that is what you use in your solution. So we are going to say 3x is equal to, and then our reduction formula in quadrant 2 is 180 minus the angle plus k times 180. For sine and cos in general solution, you use k times 360. For tan, you use k times 180. Always remember that, it is important. So 3x is then going to be equal to 180 minus our reference angle of 69.25 plus k times 180. From here, we simplify the right-hand side, and that gives us 110.75 plus k times 180. Now, we need to solve for x, so we are going to divide both sides by 3. So 3x divided by 3 is x. 110.75 divided by 3 is 36.92. And k times 180 divided by 3 is k times 60. Because this is our final solution in quadrant 2, we will use k an element of integers. When dealing with general solution, don't forget to conclude your answer in its quadrants by saying k an element of integers. So we are done with quadrant 2. Let us now focus on quadrant 4. So once again, we are going to use the angle 3x. And that is equal to the reduction formula in quadrant 4 plus k times 180 because this is tan. We substitute the reference angle. We simplify the right-hand side. From here, we divide both sides by 3 to solve for x. So 3x divided by 3 is x. 290.75 divided by 3 is 96.92. And k times 180 divided by 3 is k times 60. Because this is our final solution, we will say k an element of integers. So that is it. Please take note. All we needed to do was identify if the ratio is equal to something positive or negative, then identify our reference angle, and then lastly find our solutions in the quadrants in which tan is negative in. So that is it. Next, let us have a look at question 4.3.2. Hence or otherwise, solve for x if x is greater than or equal to negative 90 and less than or equal to positive 90. So we need to find the values of x if x is between negative 90 and positive 90. Please take note that is quadrant 1 and quadrant 4. So let us discuss this. So we know from our cost diagrams that 0 to 90 is quadrant 1. And 0 to negative 90, that is quadrant 4 from our negative cost diagram. So if we need our solution to be between negative 90 and positive 90, That means we are going to use quadrants 1 and 4. So let us go back and read our question once more. Question 4.3.2, hence or otherwise, solve for x if x is between negative 90 and positive 90. The mark allocation is 3, which means we need 3 answers or 3 values of x. And you see this word hence, it's a continuation word, meaning we have to use the solution from our previous question to solve the current question. Now, as I previously mentioned, our solutions are going to be in quadrant 1 and quadrant 4. So we need to use our solutions from the previous question to solve question 4.3.2. So we need a solution in quadrant 1 and quadrant 4. However, in the previous question, we found solutions in quadrant 2 and 4. So we cannot use the solution from quadrant 2, but we can use the solution from quadrant 4. So let us start by finding our solution in quadrant 1. So for quadrant 1, we have tan of 3x is equal to negative 2.64. From here, I'm going to move tan to the other side. So it is going to be 3x is equal to tan inverse of 2.64. Because I want my solution to be positive, because I want it to be in quadrant 1 where tan is positive, I'm going to ignore the negative sign. From here, we put this into our calculator and we end up with 69.25. We divide both sides by 3 and we have x is equal to 36.92. So that is our solution in quadrant 1. Please keep in mind there is an alternative way that we could have done this. We could have used our solution from quadrant 4 in the previous question, which was x is equal to 96.92 plus k times 60. Now this is for quadrant 4. But if we want a solution in quadrant 1, because we know that quadrant 4 and quadrant 1 are next to each other, we could have made the solution reverse, so we could have made it go backwards. To make it go in the opposite direction, you just use a negative. So we would have said x is equal to 96.92, and instead of saying plus 1 in place of k, we would have used minus 1 in place of k. So we would have stated plus, in place of k, we use a negative 1 times 60. So the negative 1 is to state that we are going in reverse. And then you put this into your calculator and you would have got 36.92. So there is an alternative way that you could have done this. Now, let us find our solution in quadrant 4. So next, in quadrant 4, we are going to use our solution from the previous question. So let's just copy this. Now I'm going to start by making k equal to negative 2. I'm not going to start at negative 1 because we know that when k is equal to negative 1, we get positive 36.92. We saw that previously when I wrote out an alternative solution to quadrant 1. So I'm going to start at the next number, which is negative 2. The reason I'm using negative 2 is because I want to have a negative answer. That's why I'm giving k a negative value. So I'm going to let k be equal to negative 2, and this is going to be x is equal to 96.92 plus, in place of k, we put negative 2 times 60. We put this into our calculator and we end up with negative 23.08. And we know that negative 23.08 is between 0 and negative 90. So that is in quadrant 4. That is our solution. Next, I'm going to try out k is equal to negative 3. So once again, in quadrant 4, so let's just copy this out quickly. And we are going to use k is equal to negative 3 this time. So we substitute negative 3 in place of x. We put that into our calculator, and we end up with negative 83.08. And that is between 0 and negative 90. So we could have kept on going, negative 4, negative 5, negative 6, etc., our values of k, to see if those are within 0 to negative 90. But we already found our 3 solutions, so we can just stop there. Because they used the word hence, we knew that we needed to use the solution from the previous question to solve the current question. So all we did was we substituted values of k to see which gives us the values we want. So that is it. All you needed to do was try to get values that are within 0 to 90 or 0 to negative 90. Next, let us have a look at question 4.4. Solve for x if 4 sine squared x plus 7 cos x minus 4 is equal to 0 and x is between 0 and 360. So keep in mind, for our solutions, we're not going to say plus k times 360 because our solution must not be greater than 360. It is restricted to quadrants 1, 2, 3, and 4, to 0 to 360. Another important thing to take note of is that it's a bit tricky to solve an equation when you have two different ratios. We have sine and we have cos. So we are going to need to turn either the sine into a cos or the cos into a sine so that we have a single ratio throughout our equation. We know sine squared x is equal to 1 minus cos squared x, which is an identity. So we are most likely going to convert everything to cos and then solve for cos x in this equation. So this is question 4.4. So from here, we are going to change sine squared x into 1 minus cos squared x, as it is better to have a single ratio in your equations when solving. So it'll become 4 into 1 minus cos squared x plus 7 cos x minus 4 is equal to 0. We distribute the 4 into the bracket. We can add up like terms. Please take note that positive 4 and negative 4 become 0. Now, something important to take note of is that we have a common factor, which is cos x. So we take out our common factor of cos x, and we are left with minus 4 cos x plus 7 is equal to 0. We separate them, so we have cos x is equal to 0, or minus 4 cos x plus 7 is equal to 0. From here, let us just solve for the equation on the right first. So we'll take 7 over to the other side, making it negative 7. We divide both sides by negative 4 to solve for cos x, and we end up with 7 over 4. We know this has no solution because 7 over 4 is greater than 1. It is outside of the range of a basic cos graph. If you want to, you can put it into your calculator. You can put cos inverse of 7 over 4. So you'll put a shift cos 7 over 4, and you'll see that you'll get an error, meaning there's no solution. Now, let us focus on the left side. We've got cos x is equal to 0. And our solution needs to be between 0 to 360. So if you're familiar with a basic cos x graph from trig graphs, you know that y is equal to 0 when x is equal to 90 or 270 in a y equals cos x graph. So you've got a few options here. You can sketch out the graph and identify the x values for which y is equal to 0. Alternatively, you can use your calculator, press mode, press table, put in cos x, start at 0, end at 360. You can make your step 90 or 45, and then you can identify all the values of x that will produce a y value of 0, and that would be your answer. For now, I'm just going to sketch out a basic cos graph between 0 to 360. So as you can see, y is equal to 0 when x is 90 and when x is 270. So we'll state, therefore, x is equal to 90 and x is equal to 270. So those are our solutions between 0 and 360. Keep in mind, like I mentioned earlier, you could have just used your calculator and then pressed mode, table. Where you see f of x, you put cos x. You start at 0, you end at 360. Your step could have been 45 or 90, and you would just identify which x values produce a y value of 0. So that is it. That is question 4.4. And that is the last trigonometry question from this KZN June 2019 exam paper. I believe after this would be trig graphs and 2- and 3-dimensional trig within this paper, if I'm not mistaken.